In this video, I am going to talk about client housekeeping. A client and an access point have to use the same modulation and coding schemes or MCS to successfully communicate. The scheme can be changed dynamically if needed, as long as both ends agree on the choice. The MCS or modulation and coding scheme directly affect the data rate between the client and the AP. An AP is configured with a set of data rates that it can use. Each data rate can be set to one of the following states: disabled, supported, and mandatory. When we configure a data rate in disabled state, it means the AP will not use the data rate for any client communication. When we configure the data rate as supported, it means the AP can use the data rate if a client also supports its use, but the client is not required to support it. And finally, when we configure a data rate as mandatory, means the AP can use the data rate and expect every client to support it. This is also known as 802.11 BSS basic rate. Okay. At least one data rate must be mandatory to provide a common rate that can be used for management and control frames. In fact, the AP will always send broadcast management frame using the lowest mandatory rate. The idea is to leverage a lower data rate to get better signal to noise ratio or SNR and greater signal range to reliably manage client devices within the BSS. Other data rate can be configured as supported. Normal data frames and unicast management frame will be sent at whatever supported rate is most optimal between the client and the AP. Acknowledgement frames are sent at the first mandatory rate that is below the current optimal data rate. APs advertise their mandatory and supported data rate in each beacon frame so that potential client can know what is available. By default, 802.11b GNN radios are configured with 1 to 5.5 and 11 megabit per second data rate as mandatory, and 802.11 A and AC radios consider 6, 12, and 24 megabit per second to be mandatory. Before a wireless device can join a BSS, it must be satisfied that it can support the AP's list of advertised data rate. The device can then announce its own set of mandatory and supported data rates in an association request frame. The AP compares the client's list of data rate with its own. If the client can support all of the AP's mandatory rate, the client can take the next step to be associated with the BSS. Wireless client can be mobile and transient. The following sections in this video describe how a wireless client and a BSS interact using management frames in a variety of common scenarios. Alright, now let me to explain about a client scans for access points. To join a BSS, a wireless device first has to scan its surrounding to look for any live APs that might offer network service. Beyond that, the device might need to build a list of SSIDs that are available. A device can scan the wireless horizon in two ways: passive scan and active scan. Let me to explain first passive scan. The device simply listens for any beacon frame broadcast from nearby APs. Passive scanning has a couple of drawbacks. A device must wait until beacons are broadcast at the next interval, which might not be soon enough in a time-critical situation. And beacons don't always contain specific SSID names, so a device cannot always depend on learning that a desired SSID exists on an AP. In this figure, host 1 is able to receive beacons from AP1 and AP2. The beacon frames specify the BSSIDs and SSIDs that are offered, as well as supported data rate and other information about their BSS. As you can see, AP1 propagate or broadcast its beacon include the BSSID of the AP1, and also the AP2 broadcast its beacon, okay, with the unique BSSID and also you know that in beacon we have some other information like the SSID and also like the data rate that each